Okay, we're looking at problem number 35. And it says, which shows an example of the multiplication property of radicals? So before I even look at those answers, let me tell you what that property looks like. The multiplication property of radicals says this: that the square root of a times b is equivalent to the square root of a times the square root of b. It simply is saying that we can take this term and split it into its parts because we're multiplying in both situations. Okay, so that is what the rule says. And we are looking at the different versions of this to see if we're getting the same concept. So let's look at A, that says 9 times 25, the square root of 9 times 25, is the same as the square root of 25 times 9. Now this is true. That is a true statement, but it does not illustrate that property that we're talking about. All we've done in this case is reverse the order of the multiplication problem. So that's not the answer, even though it is a true statement. Okay, this one we have 4 times 49 under the radical, and here you can see that splitting of terms. That's what the property is showing us. So this is the answer. You have the 4 times 49, and then you're breaking that. Because we're multiplying, we can do that. C is also true, by the way. We have 3 square root times the square root of 5 is equal to 5 square root times the square root of 3. That's true, but there's no breaking apart of the original problem. So all we've done there, again, is just reverse the order of the multiplication. It's true, but it's not illustrating the property that we want. Okay, this one we have 3 times the square root of 49, which is equal to 3 times 7. Value-wise, it's the same, but it doesn't illustrate the property. And E, we have the square root, no, sorry, it's very late and I'm just making up stuff. 6 times the square root of 16 equals square root of 6 times 16. This is not true. You can't just move the radical sign and hope for the best. So this is not equal. But the others are equal. They just don't illustrate the property that we're looking for. Okay, number 36, which is not equivalent to 25 to the 3/2 power. Well, we've talked about this concept before, that you can rewrite this as a root. It would be a square root because the bottom number is always your root. So you're taking this and moving it here, and then you are taking the 3 to go as your exponent under the house. So those problems are exactly the same value. And if you work those on your calculator, you will see that they are the same. So let's put this into the calculator just as an exponent. That's one thing about this Casio that I like very much. It will accept a fractional exponent. So you have 25 to the 3 ABC2, and that is 125. And then this, you will see, is 25 to the 3rd power is a huge number. And then if you take the square root of that number using Shift X2, you end up with 125. So mathematically I can prove that those are the same. And that's actually option A. We know that it is equal. This was A. So let's take a look at B and see what we come up with here. You've got the square root of 25 times the square root of 25 times the square root of 25. So if you simplify that, this is going to be 5 times 5 times 5, and that, if you multiply it out, is 125. So that is equal. So far we know that those are equal. 5 to the third, that's what we just did right here, expanded. That is 125. And I need some space. I'll just use the bottom here. D is the answer. If we work this out, we will see that it is not going to equal the others, because this will become, let me move this over here so we can have room to work it. You would first do your 25 squared. So 25 to the second power is 625. And then take the cubic root of that, and it is approximately 8.5. So not equal to the others. If you look at the answer choices, A turned out to be 125. B turned out to be 125. C is 125, and E is 125. So the answer to this one is D, as in dog. That's the one that does not match.